In section 7.7, there's one objective. It's number 24, which covers two things. We're going to review how to find cubed roots of real numbers, and then we're going to factor sums and differences of cubes. Both you did back in Algebra 2X. Now this question here wants us to find the cube roots of real numbers. So find the cube root of 64 other than 4. So let's just revisit what cube root means. Cube root would be this. It's typically written like this when it's in this format. And it would just say what number 3 times gives you 64. And there is a real number. It's the number 4. 4 times 4 times 4 is 64. So the cube root of 64 actually is 4. That's the real number answer. But the problem is if you write this in equation format, the cube root can also be written like this. If we had this equation and we found the cube root, you would do 1/3, you would do 1/3, you'd find the cube root of 64. Now this is a polynomial function, and the polynomial function itself, it's a cubic function, so it has 3 zeros to it. When you find the cube root in this format, you actually end up finding one of the zeros. We found one of the zeros is 4. The problem is there is 2 more zeros, and we need to be able to find them. So what I'd want to do is take the cube root of 64, which is 4, that's one of the zeros, and write it as a factor. So I know that x minus 4 is a factor of this particular equation. Well, what is this polynomial function? This polynomial function, by the way, if I just subtract 64 from both sides, is x cubed minus 64 equals 0. So what I can do is take this one factor and divide it out of this polynomial and see what's left, and then factor what's left over to find the other 2 zeros, which I know the other 2 zeros can't be real, otherwise I would have been able to get them. So let's go ahead and do that on the next slide. So what I'm going to do is take the x cubed minus 64, and I'm going to do long division of this. So this would have to be 0 plus 0x minus 64, and we're going to divide out of it x minus 4. Now when you do the long division on this, I'm just going to jump right to the answer. You're going to end up getting x squared plus 4x plus 16. So what I know is this, is that if I take the factor of x minus 4 and then this trinomial right here, it is actually going to give me x cubed minus 64, which is the same thing. Now I have this down, again that's where I get the one answer is 4. What I need to be able to do is try to factor this. And unfortunately this is not factorable over real numbers. It's factorable over imaginaries because if I try to do factoring it won't work. So to solve it, what I need to do is a quadratic formula for it. So I'm going to do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, the a I do know, so a is 1. Okay. When you simplify this, what we're going to get is a negative 4 plus or minus the square root of negative 48 all over 2. And this will ultimately break down into negative 2 plus or minus 2I, the square root of 3. So what we've done is when they're asking us to find the cube roots other than 4, we found that there's 2 other cube roots. It's negative 2 plus 2I square root of 3 and negative 2 minus 2I, the square root of 3. Again, remember that this function right here, the cube root of 64, because it can be written as a polynomial degree 3, has to have 3 zeros. It happens to be that we can only come up with the one real one on our own through the normal cube root method, but we can get the other 2, which happen to be imaginary. Now the one objective for the section only covers cubed roots. So if we want to be able to factor cube roots, if we remembered the sum and differences of cubes theorems from Algebra 2X, that'll help quite a bit. Here we go, these are the formulas for the cube roots. Now, before I show you the application of that, let's look down at this QY number 2. They want us to expand out x minus 7 all times x squared plus 7x plus 49. I'm going to tell you when you multiply that all through and distribute, you're going to end up getting x cubed minus 343. Okay, so this is a polynomial of a third degree. And what they want us to be able to do is we could apply one of these formulas up here. And let me show you how it works. The key here is, you can tell we have the subtraction, so I'm going to look at this particular equation. But it's going to be x cubed, and it's going to be minus some other number that's being cubed. So we want to be able to think, how can we rewrite this as to what number is actually being cubed? And what you're going to notice is that 7 cubed, double check it on your calculator, is going to be 343. Now that's actually the hardest part of the formula, because here's what you want to do now. Take a look at, by the way, the number that is with the x, and this is actually a 1 in front of it. So this is really 1x that's all being cubed. Okay. Now to write this formula, here's what it says to do. We're going to take this term right here, which that's the x term, and that is the y term in respect to the formula. So for this first component here, we're just going to do x minus y. Our x in this case is 1x, and the y is 7. And then we're going to do 1x all squared plus the x term, which is 1x, the y here, again, is a 7, and then it's going to be plus the 7 squared. When you simplify this, what you're going to get is x minus 7, x squared plus 7x plus 49, which is exactly what the original problem was. So this is just showing you how you can go about using the sum or differences of cubes formula. Okay, let's bring together the first slide with just finding the cube root of 64 that we did before and the formula for sum and differences of cubes in this problem. Find the cube roots of 8. So what this is asking us is, if you look at it this way, some number which is the cube root of 8. Now folks, this can be rewritten as 8 to the 1/3, right? And I'm just going backwards. Now to get rid of this, what I would do is, if what if this side was multiplied by 3? So what we can really say would be x cubed equals 8. And then in the polynomial format, it's really x cubed minus 8 equals 0. So what you want to be able to realize is, where does the statement find the cube roots of 8? What does it actually look like as a polynomial function? And this was just the math up here that kind of I did backwards to get to it. So hopefully you can see that connection. Now to find the cube roots of 8, clearly I know one of them. Right, by definition of cube root, what number 3 times gives us 8? 2. We know that 2 has to be one of them. But let's go ahead and apply the formula for either sums or differences of cubes. Now, the formula for it, I'm going to jot down right here in the green, was this again. It's that x cubed minus y cubed equals x minus y, x squared plus xy plus y squared. So we want to define from this format here, what is our x and what is our y. So if we just rewrite that, we could say this. This is, a 1x that's being cubed, and it's a 2 that's being cubed. So from that, we have our x and our y. So let's just fill in the formula. Right down here, it's going to be, it's a 1x, again, minus a 2. And then this is a 1x all squared plus 1x. The y, again, is a 2. And then plus the y squared. Simplifying that, we're going to get this. X cubed minus 8 is equal to x minus 2, x squared plus 2x plus 4. So we really had two options. We can use here the differences of cubes to factor to this point, or what we could have done is long division. What I would have done for the long division component is, let me set that up on this next slide. Long division would have looked like this. Again, you would have done the x cubed. We'd put some placeholders in for these guys right here. And we know that 2 is the real perfect cube, so we would factor out x minus 2. And again, from that, we would ultimately get the x squared plus 2x plus 4. Now, what I want you to do is pause the video and find all 3 cube roots of 8, because again, we know this is a third degree polynomial. There's 3 cube roots. One of them is real, it's 2. To find the other 2, let's use the quadratic formula on this trinomial. So pause the video and see if you get the 2 answers that I do. Hopefully you found when you did the quadratic formula, the other 2 roots are complex numbers or imaginary. One is -1 plus I times the square root of 3. The other is -1 minus I times the square root of 3. Now I want to look at 2 more, and this is just going to be based on the factoring component. So let's just factor the sums or the differences of cubes. This one right here is example 2. Factor this over a set of integers. And folks, we're going to go ahead and notice this is a subtraction format. So we're going to use the differences of cubes, which is this right here. And you just want to be careful on what the x and the y are. So let's get this original formula written down and deduce the x and y. It has to be in its cubed format. So to read it, you want to know what x is being cubed and what y is being cubed. If you take a look at this, we need to rewrite it so it has something cubed minus something cubed. And what we do is that's the x and that's the y that we would initially read and plug into the formula. So be careful when you look at this problem here, what number or what term is actually in here. It's going to be 3a, because 3a, when you cube it, is 27a cubed. So 3a is what's being cubed to get 27a cubed. Now, what is being cubed to get 8b to the 6th? Well, it has to be b squared, by the way, because you'd multiply and get 6b's, and it's 2. So what you plug in for x and y is just the 3a and the 2b squared. So let's go ahead and do that. So what we get for this is going to be 3a minus 2b squared. And then here, what we need to do is put the x value, which is 3a, and square it, plus again the other x, again, 2b squared, and then plus the y here is 2b, not y, fix that, sorry. It's going to be the 2b squared all squared. And let's write the final format. So to factor this completely, what we're going to have is a 3a minus the 2b squared. This would be 9a squared plus 6ab squared. And then this is going to leave us with 4b to the 4th power. And the answer for factoring this is we could leave it in this format. Now, typically, you would want to see if you can factor anything more fully. We cannot pull anything out of here. To factor this one, we would need factors of 9 and 4. That would add to 6. You typically would try the perfect squares of 3 and 2. We could never get just a positive 6. So this is actually all you can factor. And here's the key, too. It says factor over the integer coefficients. If I tried to factor this trinomial, they'd have to be imaginary. So we're not going to go any further. And that's how I know to stop, is that they only want integer coefficients, so don't go any further like we did when we found the cube roots of 8. This last problem is worth looking at because they want us to factor again over the set of polynomial with real coefficients. Again, which means we don't want any imaginary numbers, so we have to go that route. We won't. But this is a plus symbol here, which means we need to do the other formula, and let me write that one down. It's x cubed plus y cubed. The only difference is here we have a plus, and then we have a subtraction sign right here. And we want to do the same type of problem. Now, the difference is they want real coefficients, so I can have real numbers. If it's at integer coefficients, then I can only put positive or negative whole numbers in this factoring, and then I would stop. To do this one, again, we need to identify what is the x and what is the y that's being cubed. So if you take this, we can clearly see that it's the x that's being cubed. But what is being cubed here to get us 10? Well, if you think about it, what number 3 times gives us 10. There is no such integer number. It was a real number. So think of it this way. Some number, 3 times is 10. How do you find it? Well, you would take the cube root. So the answer here is the cube root of 10 is what the y value actually is. So let's go into the formula. That's my x value and that is my y value, and plug it all in. So to factor this completely over real coefficients, because this is a real number, just do this. So we're going to do x, and it's b plus the cube root of 10. And the second component, we're going to take an x and square it. Minus, we're going to take that x again. Then the cube root of 10. Plus the cube root of 10 all squared, and simplify this. So if we simplify it, it'll just look like this. X squared minus, here the coefficient is the cube root of 10. We put that first and then the variable. And then to simplify this, what you could do is square 100. Or square 10, I'm sorry, in which actually you get 100. So this right here is the fully factored over the real coefficients this time. Again, if this problem had said factor over the integer coefficients, we couldn't do this over the integer coefficients because this itself is not an integer. And that's how you do this section. Now for this section, there is no book assignment. Look in your note packet. There's 4 problems I want you to do. Number 1 and number 2 is a 3rd degree binomial, and I want you to factor it and find the roots. So the final answer is I actually want the roots for it and the factored format. So make sure you do both. Show me what this looks like completely factored. In addition, state the roots. Okay. And then the last 2, number 3 and number 4, it's just asking you to factor. And these 2, what I would do is just use the sum or the differences of cubes formula to do that. Number 1 and number 2, you can partially use the formula or you can use long division to help you out. 3 and 4, I would suggest just using the formula for that, and you should be good.